So, good afternoon, guys. In the previous session, we have discussed about some classification algorithm, which is decision tree algorithm and random forest algorithm. So, in today's session, we are going to discuss about the one of the unsupervised learning algorithm. Right. So, as I said in the previous sessions itself, that we have under supervised learning we have supervision, right? But in case of unsupervised learning we don't have any supervision, and we used to have label data under supervised learning because we are going to use the data for which the output is known. Okay, such samples will be used to learn the machine, to train the machine, right? So for example, like if you want to know the rainfall, okay, so how much tomorrow the rain may come, so how much how much the quantity will be, or whether the rain will come or not. So to know such things, the machine has to be fed with the previous data, previous like about 5 to 10 years of information, that what might be the temperature, what was the temperature and what is the climatic condition, or whether rain has come on that particular day or particular moment of time, keeping that climatic condition, or the the temperature, humidity, air, wind pressure, air pressure. So all the stuffs, whether the rain has come or not, so all those stuffs will be given to the machine, so that the machine will gain the information about the rainfall, like what in which kind of scenario the rain may come, which kind of how much temperature, like within how much temperature the rain would come. Okay, and if the humidity is about 50% or 60%, whether the rain will come or not. So all the stuffs will be understood by the machine. Okay. And to make understand the machine about the data, the machine has to be fed with the proper information, right? In some cases we don't have any output, right? So depending on the entire information that we have in our hand, so we have to use them in for the different purposes, right? So and like for example, we have customer information, whether about who are going to shop in a mall, right? So and the set of customers will go into a shopping mall, and they'll purchase some goods, and they purchase vegetables, they purchase fruits, they purchase clothes, some purchase toys and all those stuffs. But we have all those information: who is the customer, what's his address, and what is his phone number, what is his occupation, and what is his what are the list of items that he or she have purchased, and what is the cost of every item, and what's the total bill, and what's the frequency of their visit to the shop, visit to the mall, okay, in a month or in a week. Okay, all this information we have in our hand, but we don't know the actual output, well, like what purpose, for predicting or determining what thing we are going to use this information. We just have to know that, we just have to implement our criteria, implement our understanding of the pattern of distribution of the data set, like how the customers are distributed throughout week, throughout the month, or for the different products. Okay, we have to understood that thing, and keeping that in mind, we have to introduce, like being a mall owner, we can introduce some schemes, so we can use the entire data set for that purpose, or we can use the information for marketing purpose, for introducing new schemes, or for storing, or the emptied, or reduced quantity, or how much items are already sold, and now to restore the products, okay, in the shop. Okay. And for billing, and for giving a honor or a reward for any particular customer. So all those stuffs, for all those stuffs we can use this. Okay, so there the output is not known, is not actually one. Okay, we can use this information for different purposes, right? So similarly, we have some data, we have we may came some situation, for that we in that situations we may not know the output, but we have to use the information in some or the other way. I had to understood that information in some or the other way, and we have to apply it for any whatever the outcome we need at any particular moment of time. Okay, in such cases this kind of learning, that is unsupervised learning, will be helpful. Okay, and in unsupervised learning, what happens, there is no supervision, there is no label data. Okay, so the machine has to understood the what kind of pattern of distribution of the data in the entire data set, and how the feature is affected, how the feature is varying, particular feature values are varying, whether it is slowly increasing or slowly decreasing, or for this particular person this will be the cost, for this will be the cost, and this will be the sales. So this is how the machine has to understood the pattern of distribution of the entire data set. Okay, so that it has to understood on its own about the data set, and it has to predict the results, and it has to group up some like similar data items in one or the other way, or split ups like from the entire data set. It has to groups, it has to create a groups. Okay, so that similar data items or the similar featured samples will come and sit under one group. Okay, so and that kind of learning will be referred as your unsupervised learning. Okay, so under unsupervised learning, mainly there are two types of algorithms. One is clustering, another one is association. But coming to the working procedure, almost all both are like in both are very close to each other. Okay, so in clustering also we are going to make the groups, in association also we are going to make the groups, but what makes it the reason for making the groups, that makes the difference of these two algorithms. Okay, so and the main and the majority used algorithms are belongs to this category, that is clustering. Okay, so that is like a majorly the most popularly used algorithm or the method to make the machine to learn is what your clustering algorithms. Okay, and what actually the clustering, so clustering as the name itself gives us the meaning, like clustering is nothing but making the clusters are nothing but groups. Right, so creating a clusters, creating a groups based on some criteria, based on some strategies. Okay, and how it makes the clusters and how it is going to be created, so that makes the algorithm difference. Okay, and out of all those clustering algorithms, like we have many clustering algorithms, and we have different classification of clustering also, so I'll come to that later. Okay, and in today's session, so we are going to concentrate on mainly on k-means clustering. Okay, so k-means clustering is what your point of discussion in today's session. Okay, so just a sec, I'll show you. Just a sec. So we'll be having different types of clustering algorithms, and out of those, two are mainly classified, two types. Okay, so clustering are mainly classified into two types. One is agglomerative and another one is divisive. Okay, so you can just take a note of this point. Just a sec, I'll show that classification. So these here are the types of clustering, and when where you are going to have different types of clustering algorithms. And clustering is mainly categorized into two parts. One is like two types. One is hierarchical clustering and partitional clustering. Okay. And coming to the hierarchical clustering, so we have some more types in under hierarchical clustering, called as agglomerative and divisive. And in coming to the partitional clustering, we have two types, like k-means clustering and fuzzy c-means clustering. Okay. And most commonly used algorithms, or most commonly used clustering techniques are hierarchical clustering, and coming to the partitional clustering, k-means clustering is the most commonly used clustering technique. Okay. And coming to the hierarchical clustering will be like how it is done. Okay. So that is what makes it difference from the other part. Okay. And clustering, I'm coming to the hierarchical clustering. In this method of clustering, in this way of machine learning, so clusters have a tree like structure or a parent child relationship. Okay. So this kind of clusters will be created. Okay. Tree like structure will be created after putting some other conditions, or the formulas, or the equations. Okay. By satisfying those conditions, or by getting the values from those expressions, the tree will be created. Okay. So we'll be having a parent child relationship in this kind of hierarchical clustering. Okay. And in this also we'll be having two types. One is agglomerative clustering and divisive clustering. So in case of agglomerative clustering, so it is a bottom up approach. That means like whatever the samples you have in your data set, so all those samples will be treated as a individual output, individual cluster at the beginning. And after that the similarity, like by searching out the similarity between the samples, like one sample is might be similar to one or the other samples. Okay. So, and those similar samples will be grouped. Okay. So, and this process will be continued until and unless we will get a single cluster. Okay. So this is how the clustering this is how the tree will be created. Okay. So here the approach will be like bottom up approach, and we will begin with each element as a separate cluster and merge them into a successive larger clusters. Okay. By finding out the similarities. Okay. So this kind of building up the tree and grouping the samples, or the creating a clusters, is called as agglomerative clustering. And in case of divisive clustering, what happens? And in case of divisive clustering, what happens? It's like as the name itself suggests, it is divisive. That means divisible. So it is going to split up on every step. Okay. So that's why it is called as a top down approach. Begin with one whole set and proceed to divide it into a successive smaller clusters. That means our like entire data set will be treated as one cluster, like whatever the samples will be having in our data set, whatever the rows will be having in our data set, all those samples, all those information will be treated as, will be put in a single cluster. And what makes it difference from one to other sample? So thereby it will going to that particular sample will be separated from the cluster. Okay. So likewise the entire cluster will be divided and further. Okay. And thereby finally and will get each and every sample as a individual cluster. Okay. So that is what the final result of divisive clustering. Okay. We'll be having multiple groups in a divisive clustering, and we'll be having a single group in agglomerative clustering. Okay. And coming to the other part, that is partitional clustering. So partitional clustering, as the name itself suggests, it is going to partition, it's going to divide the clusters. Okay. How it makes the clusters? So that makes it makes two types. One is k-means, other one is fuzzy c-means. What happens in k-means clustering, like the entire data set will be grouped into a like entire data set. That means entire samples will be having in our data set. So all will be grouped under specific clusters. Okay. So in two or more, like it can be like n number of clusters we can have, and that n number of clusters is represented by the letter k. Okay, k means that is nothing but k represents the number of clusters here. Okay, how many number of clusters that you are going to consider is up to you. Okay, so but choosing the k value is also matters for like getting the highest accurate results. Okay, and that is also, that should also be in a proper way. So for that purpose, choosing the k value, there's a specific method called elbow method. Okay, so by drawing that graph, we are going to get the proper k value. Okay, so don't worry, I'll explaining the demonstration, so we'll get to know that how that elbow method will be implemented and how we can choose the k value. Okay, so initially we'll usually start with 2 and minimum 2. Okay, and we can go up to n. Okay, and in case of this, the entire data set or the entire samples will be divided into a different clusters, and these clusters are disjoint. Disjoint is nothing but, so those like there will be a no common sample between every cluster. Like, okay, so each and every cluster there will be a no single sample will be present. Okay, like one sample is completely belong to one cluster, not like one sample will belong to both the clusters or multiple more than 2 clusters. So there is nothing such things will be present in case of k-means clustering. In such way we are going to group the samples. Okay, so that will be happened in case of k-means clustering. Okay, so here what happens, the division of objects into a cluster such that each and every object is in exactly one cluster, not several. Okay, so they are not belong to like multiple clusters. Okay, it is exactly completely belong to only one cluster. Okay, so that kind of clustering will be happening in case of k-means clustering, and in case of fuzzy c-means clustering, what happens, division of objects into clusters such that each object can belong to multiple clusters. So unlike k-means, in case of fuzzy c-means, what happens, like one sample can be belong to the multiple clusters. Okay, one sample can belong to the multiple clusters can happen. Okay, and in this way of clustering will be happen in case of c-means clustering, and that is how the groups or the clusters will be created. Okay, so and that kind of clustering will be happen in case of c-means clustering. Okay, and coming to the our point of interest or point of center point of topic is about k-means clustering. So we are concentrating today on the specifically a specific clustering technique called as k-means clustering technique. Okay, so and all these are like almost all the clustering techniques are most used in the like one or the other problem. Okay, but k-means is very easiest and very easy to understand and easy to implement algorithm. Okay, so that is why we have chosen to like a k-means algorithm to explain, so that you can easily understand it, and thereby you can get the advantages and the applications of these k-means clustering and how this unsupervised learning is generally happen. Okay, so that can be easily understood by you people. Okay. What happens in k-means clustering? Okay, so if we just start with an example. Okay, so how like as I said, in case of k-means clustering, we'll used to have the clusters like, and that cluster numbers, that count can be represented by k. Okay, and how this clustering will be happen. Okay, so that we shall discuss now. Okay, so we shall start with an example. Okay, so for understanding the k-means algorithm, so we shall take an example of cricket. Okay, so what is our task? So our task is to identify bowlers and batsmen. Okay, that is that is how we have to create our clusters. Okay, and that data can contain like whatever the data in our hand that contains the information about runs and wickets gained in the last 10 matches, who scored how many runs and who got how many wickets. Okay, so that kind of information will be having in our data set. So we based on that stuff, we have to find out who are the bowlers and who are the batsmen. We didn't have any information about that he is the bowler, he is the batsman, so that kind of information we didn't have in our data set. We just have the information about the cricketer and how much run he has scored and how much wickets he has got. Okay, so that information we have in our hand. So by using this data set, we have to find out who are the bowler and who are all the batsmen. Okay, we have to separate them. We have to give the output as a set of bowlers and set of batsmen. And how do you think, how do you decide whether he is a bowler or he is a batsman? Okay, so just think of it. And how do you think that he is a bowler? Okay, so bowler used to have like more than runs scored, he used to have the wickets, right? So bowlers so ಜಾಸ್ತಿ ಕ್ರಿಕೆಟ್ ಪ್ಲೇ ಮಾಡೋದಕ್ಕಿಂತ ಅಂದರೆ ಬ್ಯಾಟಿಂಗ್ ಮಾಡೋದಕ್ಕಿಂತ ಜಾಸ್ತಿ ಅವರು ವಿಕೆಟ್ಸ್ ತೊಗೋತಾರೆ, ರೈಟ್? ಸೊ ಬೌಲರ್ಸ್ ಯಾರು ಎಕ್ಸ್ಪರ್ಟ್ ಇದ್ದಾರೆ, ಇವರು ತುಂಬ ಎಫಿಷಿಯೆಂಟ್ ಬೌಲರ್, ಈ ಥರದ್ದೆಲ್ಲ ಏನು ಹೇಳ್ತೀವಿ. ಸೊ ಅವ್ರು ಏನು ಮಾಡ್ತಾರೆ, ಜಾಸ್ತಿ ವಿಕೆಟ್ಸ್ನ ತೊಗೊಂಡಿರ್ತಾರೆ. ಬಟ್ ಬ್ಯಾಟ್ಸ್ಮನ್ಸ್ ಏನು ಮಾಡಿರ್ತಾರೆ, ಬೌಲಿಂಗಿಂತ ಜಾಸ್ತಿ ಬ್ಯಾಟಿಂಗಿಗೆ ಕಾನ್ಸಂಟ್ರೇಟ್, ಲೈಕ್ ಫೀಲ್ಡಿಂಗಲ್ಲಿ ಕಾನ್ಸಂಟ್ರೇಟ್ ಮಾಡ್ತಾ ಇರ್ತಾರೆ, ಲೈಕ್ ವೆನ್ ಅದರ್ ಸೈಡ್ ಈಸ್ ಬ್ಯಾಟಿಂಗ್. ಓಕೆ, ಬ್ಯಾಟ್ಸ್ಮನ್ಸ್ ಏನು ಮಾಡ್ತಾರೆ, ಜನರಲಿ ದೇ ಯೂಸ್ ಟು ಹ್ಯಾವ್ ದ ಹೈಯೆಸ್ಟ್ ಸ್ಕೋರ್ಸ್ ಫಾರ್ ರನ್ಸ್. Okay. So based on this stuff, we can easily analyze that who are all the bowlers and who are all the batsmen. Okay, so what we'll do next is, so is to assign the data points first. So here we have the data set with the x and y coordinates, and x will represent the wickets and y will represent the runs, and the person who have scored less will have highest wickets, and person who have highest scores will score with lowest wickets, right? So ತುಂಬ ಜಾಸ್ತಿ ರನ್ಸ್ ಸ್ಕೋರ್ ಮಾಡಿರೋರು ವಿಕೆಟ್ಸ್ ಕಡಿಮೆ ತೊಗೊಂಡಿದ್ದಾರೆ, ಜಾಸ್ತಿ ವಿಕೆಟ್ಸ್ ತೊಗೊಂಡಿರೋರು ಕಡಿಮೆ ರನ್ಸ್ನ ಸ್ಕೋರ್ ಮಾಡಿದ್ದಾರೆ. ಸೊ ಇದ್ರ ಬೇಸ್ ಮೇಲೆ ನಾವು ಡಿಸೈಡ್ ಮಾಡ್ಬೋದಲ್ವ ಹೂ ಆರ್ ಆಲ್ ದ ಬೌಲರ್ಸ್, ಹೂ ಆರ್ ಆಲ್ ದ ಬ್ಯಾಟ್ಸ್ಮನ್ಸ್ ಅಂತ. ಬಟ್ ದ machine has to understand this. So for this purpose, what we are going to use is the specific strategy called as CLAY, means clustering. Okay, and here in the K means clustering, we want to cluster the entire data set. Okay, so into our two groups specifically, and these two groups is belongs to one group is about set of cluster of bowlers, one other is of batsmen. Okay, so in the cluster one, we can see that the cluster has the players with the highest runs and low wickets. So highest runs, low wickets is nothing but, so this is the cluster of batsmen. Okay, and on the other side we have clusters, the cluster that has players with the highest wickets and lower wickets, sorry, highest wickets and lower scores. Okay, so lower scores is the highest wickets ಇದೆ ಅಂತ ಹೇಳಿದ್ರೆ, so that is the cluster of bowlers. Right, and initially we'll start with a point, like we'll find out two centroids. Okay, so randomly we choose two centroids, and these two centroids are not, it's not like mandatory that we have to choose the point among our data set. Okay, ನಮ್ಮಲ್ಲಿರೋ ಡಾಟಾ ಸೆಟ್ಟಲ್ಲಿ ಯಾವುದೋ ಒಂದು ಪಾಯಿಂಟ್ನ ಕಾಮನ್ ಆಗಿ ತೊಗೋಬೇಕು ಅಂತ ಏನಿಲ್ಲ, ವಿ ಕ್ಯಾನ್ ಚೂಸ್ ಇಟ್ ಬೈ ರ್ಯಾಂಡಮ್. ಓಕೆ, ಸೊ ಆ್ಯಂಡ್ machine will like randomly chooses two centroids, and for these two centroids, whatever the data points are there in our data set. Okay, so just calculate the Euclidean distance for this centroid. So what is the distance of what will be the distance of a particular cluster okay, centroid, cluster centroid ಇಂದ ಯಾವ ಪರ್ಟಿಕ್ಯುಲರ್ ಪಾಯಿಂಟಿಗೆ ಯಾವ ಪರ್ಟಿಕ್ಯುಲರ್ ಪಾಯಿಂಟ್ ಯಾವ್ಯಾವ ಪಾಯಿಂಟ್ಸ್ ಹತ್ತಿರ ಆಗುತ್ತೆ. Okay, so for example, here we have a blue and orange centroids. Okay, so whichever the points which are nearer to the blue centroids will be grouped and will be making as one cluster, and whichever the points which are nearer to the orange cluster will be making as which is nearer to the orange cluster. Okay, so and thereby we are going to calculate that we are going to separate them. Okay, so afterwards we are going to cluster them. Okay, so by finding out the Euclidean distance between every points. Okay, so to the centroid, between the centroid and the data point. Okay, between the centroid and the data point, so what is the distance between this point and the centroid? So what is the distance between this point and the centroid? Okay, so that's that thing we are going to calculate, and which will be having the less distance. So ಈಗ ಯಾವ್ಯಾವ ಡಾಟಾ ಪಾಯಿಂಟ್ಸ್ ಬ್ಲೂ ಕ್ಲಸ್ಟರಿಗೆ ಅಂದರೆ ಬ್ಲೂ ಸ್ಟಾರಿಗೆ ದಟ್ ಈಸ್ ನಥಿಂಗ್ ಬಟ್ ಒನ್ ಕ್ಲಸ್ಟರ್, ಸೊ ದಟ್ ಇಸ್ ದ ಸೆಂಟ್ರಾಯ್ಡ್. ಆ ಸೆಂಟ್ರಾಯ್ಡಿಗೆ ಹತ್ತಿರ ಆಗ್ತದೆ ಅದನ್ನೆಲ್ಲ ಆ ಕ್ಲಸ್ಟರ್ಗೆ ಜಾಯಿನ್ ಮಾಡ್ತೀವಿ. ಆ್ಯಂಡ್ ಆರೆಂಜ್ ಸೆಂಟ್ರಾಯ್ಡಿಗೆ ಯಾವುದ್ಯಾವುದು ಹತ್ತಿರ ಇದೆ, ನಿಯರ್ ಬೈ ಇದೆ, ಸೊ ಅದನ್ನೆಲ್ಲ ನಾವು ಈ ಕ್ಲಸ್ಟರಿಗೆ ಜಾಯಿನ್ ಮಾಡ್ತೀವಿ. ಓಕೆ, ಸೊ ಆ್ಯಂಡ್ ದಟ್ ಈಸ್ ಹೌ ವಿ ಆರ್ ಗೋಯಿಂಗ್ ಟು find out the clusters and find out the data points which are being to be present in a different clusters. Okay, after that what happens in the next iteration? So that is the first thing, it is going to happen in the first iteration. And after that, in the second iteration, what happens, the centroid will be changed. ಓಕೆ, ಸೊ ಈಗ ಇನಿಷಿಯಲಿ ಹೇಗೆ ತೊಗೊಂಡಿರ್ತೀವಿ, ಲೈಕ್ ರ್ಯಾಂಡಮಾಗಿ ಒಂದು ಪಾಯಿಂಟ್ ಅಂತ ತೊಗೊಂಡಿರ್ತೀವಿ, ದಟ್ ಈಸ್ ನಾಟ್ ದ ಆ್ಯಕ್ಚುಯಲ್ ಸೆಂಟ್ರಾಯ್ಡ್ ಫಾರ್ ದ ಕ್ಲಸ್ಟರ್. ಅದೊಂದು ಆ್ಯಕ್ಚುಲಿ ಸೆಂಟ್ರಾಯ್ಡಿಗೆ ಒಂದು ಕ್ಲಸ್ಟರಿನ ಸೆಂಟ್ರಾಯ್ಡ್ ಎಕ್ಸಾಕ್ಟ್ಲಿ ಸೆಂಟ್ರಲ್ಲಿ ಬರೋವಂಥ ಪಾಯಿಂಟ್ ಆಗಿರೋದಿಲ್ಲ. ಓಕೆ, ರ್ಯಾಂಡಮಾಗಿ 2 ಪಾಯಿಂಟ್ ಚೂಸ್ ಮಾಡಿರ್ತೀವಿ ಅಷ್ಟೇ. ಸೊ ಆ 2 ಚೂಸ್ ಮಾಡಿರುತ್ತೆ ಅಷ್ಟೇ. ಆ್ಯಂಡ್ ಆ 2 ಪಾಯಿಂಟ್ಸಿಗೆ ಯಾವ್ಯಾವೆಲ್ಲ ಡಾಟಾ ಪಾಯಿಂಟ್ಸ್ ಹತ್ತಿರ ಆಗುತ್ತೆ, ನಿಯರ್ ಬೈ ಆಗುತ್ತೆ, ಬೈ ಕ್ಯಾಲ್ಕುಲೇಟಿಂಗ್ ದ ಯೂಕ್ಲಿಡಿಯನ್ ಡಿಸ್ಟೆನ್ಸ್ ವಿ ಆರ್ ಗೋಯಿಂಗ್ ಟು ಗ್ರೂಪ್ ಅಪ್ ದ ಎಂಟೈರ್ ಡಾಟಾ ಪಾಯಿಂಟ್ಸ್ ಡಾಟಾ ಸ್ಯಾಂಪಲ್ಸ್ ಇಂಟು ಅ ಡಿಫ್ರೆಂಟ್ ಕ್ಲಸ್ಟರ್ಸ್. ಸೊ ಆಫ್ಟರ್ ದ್ಯಾಟ್ ವಿ ಆರ್ ಗೋಯಿಂಗ್ ಟು ಫೈಂಡ್ ಔಟ್ ದ ಎಕ್ಸಾಕ್ಟ್ ಸೆಂಟ್ರಾಯ್ಡ್. ಓಕೆ, ಸೊ ಅದಾದಮೇಲೆ ಏನು ಮಾಡ್ತೀವಿ, ಎಕ್ಸಾಕ್ಟ್ ಸೆಂಟ್ರಾಯ್ಡ್ ಯಾವ್ದು ಬರುತ್ತೆ ಫೈಂಡ್ ಔಟ್ ಮಾಡ್ತೀವಿ. ಆ್ಯಂಡ್ ಆ ಸೆಂಟ್ರಾಯ್ಡ್ನ ಫೈಂಡ್ ಔಟ್ ಮಾಡಿದ್ಮೇಲೆ ಅಂದರೆ ಎಲ್ಲಿ ಬರ್ಬೋದು ಆ ಡಾಟಾ ಪಾಯಿಂಟ್, ಸೊ ಅದನ್ನ ಈಗ ನೀವು ಥರ್ಡ್ ಫಿಗರಲ್ಲಿ ನೋಡ್ತಾ ಇದ್ದರೆ ಸೆಂಟ್ರಾಯ್ಡ್ ಪಾಯಿಂಟ್ ಹ್ಯಾಸ್ ಬಿನ್ ಚೇಂಜ್ಡ್. ಸೊ ಸೆಂಟ್ರಾಯ್ಡ್ ಪಾಯಿಂಟನ್ನು ಚೇಂಜ್ ಮಾಡಿದಾಗ ಏನಾಗುತ್ತೆ, ಸೊ ಅಲ್ಲಿಗೆ ಅದು ಹೊಸ ಪಾಯಿಂಟ್ ಬರುತ್ತೆ. ಸೊ ಆ ಪಾಯಿಂಟಿಗೆ ನಾವು ಮತ್ತೆ ಡಿಸ್ಟೆನ್ಸ್ನ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ತೀವಿ ವಿತ್ ಆಲ್ ಅದರ್ ಡಾಟಾ ಪಾಯಿಂಟ್ಸ್. ಮತ್ತು ಎಲ್ಲ ಪಾಯಿಂಟ್ಸಿಗೆ ಆಲ್ರೆಡಿ ಕ್ಲಸ್ಟರ್ಸ್ ಆಗಿದೆ, ಸೊ ಆ ಕ್ಲಸ್ಟರ್ಸ್ ಆಗಿರೋ ಡಾಟಾ ಪಾಯಿಂಟ್ಸಿಗೆ ಮತ್ತೆ ಈ ಚೇಂಜ್ ಆಗಿರೋ ಸೆಂಟ್ರಾಯ್ಡ್ ಜೊತೆ ಡಿಸ್ಟೆನ್ಸ್ನ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ತೀವಿ. ಸೊ ಈ ಥರ ಡಿಸ್ಟೆನ್ಸ್ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಿದಾಗ ಯಾವುದಾದ್ರೂ ಡಾಟಾ ಪಾಯಿಂಟ್ಸು ಒಂದು ಕ್ಲಸ್ಟರಿಂದ ಇನ್ನೊಂದು ಕ್ಲಸ್ಟರಿಗೆ ಮೂವ್ ಆಗುತ್ತಾ ಚೆಕ್ ಮಾಡ್ತೀವಿ. ಓಕೆ, ಸೊ ಅಂಟಿಲ್ ಆ್ಯಂಡ್ ಅನ್ಲೆಸ್ ವಿ ಗೆಟ್ ದ ನೋ ವೇರಿಯೇಷನ್ ಇನ್ ಎನಿ ಡಾಟಾ ಪಾಯಿಂಟ್ಸ್ ಫಾರ್ ಇನ್ ಮೂವಿಂಗ್ ಬಿಟ್ವೀನ್ ಕ್ಲಸ್ಟರ್ಸ್. ಓಕೆ, ಸೊ ಅದರ ಕ್ಲಸ್ಟರ್ಸ್ ಒಂದು ಡಾಟಾ ಪಾಯಿಂಟು ಪ್ರೀವಿಯಸ್ಲಿ ಈಗ ಕ್ಲಸ್ಟರ್ 1ನಲ್ಲಿತ್ತು, ನೆಕ್ಸ್ಟ್ ನಾವು ಸೆಂಟ್ರಾಯ್ಡ್ ಚೇಂಜ್ ಮಾಡಿದ್ಮೇಲೆ ಕ್ಲಸ್ಟರ್ 2 ಹೋಯಿತು, ಈ ಥರದ್ದೇನಾದರೂ ಆಗೋವರೆಗೂ ಅಲ್ಲಿಗೆ ಆಗ್ತಾ ಇತ್ತು ಅಂದರೆ ನಾವು ಅಗೇನ್ ಆ್ಯಂಡ್ ಅಗೇನ್ ವಿಲ್ ಗೋಯಿಂಗ್ ಟು ರಿಪೀಟ್ ದ ಸೇಮ್ ಪ್ರೊಸೆಸ್. ಸೆಂಟ್ರಾಯ್ಡ್ ಚೇಂಜ್ ಮಾಡ್ತೀವಿ, ಕ್ಲಸ್ಟರ್ಸ್ನ ಸೊ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ತೀವಿ. ಓಕೆ, ಸೊ ಅಂಟಿಲ್ ಆ್ಯಂಡ್ ಅನ್ಲೆಸ್ ವಿ ಗೆಟ್ ದ ನೋ ವೇರಿಯೇಷನ್ ಇನ್ ಎನಿ ಡಾಟಾ ಪಾಯಿಂಟ್ಸ್ ಇನ್ ಚೇಂಜಿಂಗ್ ದ ಕ್ಲಸ್ಟರ್ಸ್, ವಿ ಗೋಯಿಂಗ್ ಟು ಕಂಟಿನ್ಯೂ ದಿಸ್ ಪ್ರಾಸೆಸ್. ಆ್ಯಂಡ್ ಫೈನಲಿ ವಾಟ್ ಹ್ಯಾಪನ್ಸ್, ಫೈನಲಿ ಎಲ್ಲಿಗೆ ನಿಲ್ಲಿಸ್ತೀವಿ, ಎಲ್ಲಿ ವೇರಿಯೇಷನ್ಸ್ ಬರೋಲ್ಲ ಅಲ್ಲಿಗೆ ಸ್ಟಾಪ್ ಮಾಡ್ತೀವಿ. ಸೊ ಫಾರ್ ದಿಸ್ ಡಾಟಾ ಸೆಟ್ ವಿ ಹ್ಯಾವ್ ಅ ಕ್ಲಿಯರ್ ಸೆಟ್ ಆಫ್ ಡಾಟಾ ಪಾಯಿಂಟ್ಸ್ ವಿಚ್ ವಿಲ್ ಬಿ ಇನ್ ಕ್ಲಿಯರ್ ಝೋನ್. ಓಕೆ, ಕ್ಲಿಯರಾಗಿ 2 ಕ್ಲಸ್ಟರ್ ಪಾಯಿಂಟ್ ಆಗಿದೆ. ಬಟ್ ಸಮ್ ಪಾಯಿಂಟಲ್ಲಿ ಏನಾಗುತ್ತೆ, ತೀರಾ ಬಾರ್ಡ್ರಲ್ಲಿ ಆ ಕ್ಲಸ್ಟರ್ ಒಂದು ಕ್ಲಸ್ಟರ್ ಇನ್ನೊಂದು ಕ್ಲಸ್ಟರ್ ತೀರಾ ಬಾರ್ಡ್ರಲ್ಲಿರೋಂಥ ಡಾಟಾ ಪಾಯಿಂಟ್ ಇಟ್ ಮೇ ವೇರಿ. ಇಟ್ ಮೇ ಲೈಕ್ ಒಂದ್ಸಲ ಒಂದು ಕ್ಲಸ್ಟರಲ್ಲೇ ಬರ್ಬೋದು, ಅಥವಾ ನೆಕ್ಸ್ಟ್ ಟೈಮ್ ಇನ್ನೊಂದು ಕ್ಲಸ್ಟರ್ಗೆ ಅದು ಮೂವ್ ಆಗೋ ಚಾನ್ಸಸ್ ತುಂಬ ಜಾಸ್ತಿ ಇದೆ. ಸೊ ಆ ಥರ ಪಾಯಿಂಟ್ಸ್ ಆಯಿತು ಅಂದರೆ ಮತ್ತೆ ನಾವು ರೀಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ತೀವಿ, ರಿಫೌಂಡ್ ಮಾಡ್ತೀವಿ whether the data point has been in a cluster 1 or cluster 2 or cluster 3 or something else. ಸೊ ಈ ಥರ ಪಾಯಿಂಟೆಡ್ ಮಾಡ್ತೀವಿ. ಸೊ ಅದಾದಮೇಲೆ ಫೈನಲಿ ಎಲ್ಲ ಕ್ಯಾಲ್ಕುಲೇಷನ್ಸ್ ಆಗಿ ಇನ್ನು ನೆಕ್ಸ್ಟು ಯಾವುದೇ ವೇರಿಯೇಷನ್ಸ್ ಆಗ್ತಾ ಇಲ್ಲ ಅಂದಾಗ ವಿಲ್ ಸ್ಟಾಪ್ ಇಟ್. ಸೊ ದೇರ್ ವಿಲ್ ಫೌಂಡ್ ಔಟ್ ದ ಕ್ಲಸ್ಟರ್ಸ್. ಓಕೆ, ಸೊ ಅಲ್ಲಿಗೆ ನಮಗೆ ಕ್ಲಸ್ಟರಿಂಗು ಕಂಪ್ಲೀಟ್ ಆಗುತ್ತೆ. ಓಕೆ, ಸೊ ದಿಸ್ ಇಸ್ ಹೌ ಕೆ ಮೀನ್ಸ್ ಕ್ಲಸ್ಟರಿಂಗ್ ವಿಲ್ ಗೋಯಿಂಗ್ ಟು ಬಿ ಫೌಂಡ್ ಆ್ಯಂಡ್ ಇಟ್ ವಿಲ್ ಗೋಯಿಂಗ್ ಟು ಗಿವ್ ದಸ್ ದ ನಂಬರ್ ಆಫ್ ಕ್ಲಸ್ಟರ್ಸ್. Okay, so that is how we are going to get the results of clustering. K means clustering. Okay, and so we shall see the example of this K means clustering. So afterwards we will get to know that how it will be worked exactly, and how this will be done properly. Okay, so just a sec. So what happens, so we shall move on to the demo afterwards. So we shall complete the theoretical part first. So what are all the different applications of K-means clustering? So the different applications of K-means clustering is here: academic performance, to find out to group up the students based on their performance, based on their grades. So we can group up the students so that the slow learners will be given with some more materials or some more classes, whatever the action to be taken, so that will be taken care of, and higher bright students can be given with the few chances, or like sending out those students who out of the competitions, all those stuffs we can do it for the brighter students, and slow and medium students will just work on more for those students. So these kind of strategies we can being a teachers they can make. Okay, and diagnostic systems to categorize a particular disease. Okay, and search engines to get the information, like if you used to search for anything by using any keyword. Okay, so you just have a set of links. Okay, so that set of links will be given on what basis? So by using this similarity basis. Okay, so ನೀವು ಯಾವುದೇ ಒಂದು ವರ್ಡನ್ನು ಸರ್ಚ್ ಮಾಡ್ತಾ ಇರ್ತೀವಿ, ಯಾವುದೋ ಒಂದು ವೆಬ್ಸೈಟ್ನ ಸರ್ಚ್ ಮಾಡ್ತೀರ, ಯಾವುದೊಂದು ಅಪ್ಲಿಕೇಶನ್ನೋ ಅಥವಾ ಯಾವುದೋ ಒಂದು ಪ್ರೋಗ್ರಾಮಿಂಗ್ ಲ್ಯಾಂಗ್ವೇಜ್ ಮೆಟೀರಿಯಲ್ನೋ ಅಥವಾ ಏನೋ ಸರ್ಚ್ ಮಾಡ್ತೀರಾ. ಸೊ ಏನೋ ಸರ್ಚ್ ಮಾಡಿದ ತಕ್ಷಣ ನಿಮ್ಗೇನು ಬರುತ್ತೆ, ಒಂದು ಲಿಸ್ಟ್ ಆಫ್ ಲಿಂಕ್ಸ್ ಬರುತ್ತೆ, ರೈಟ್. ಸೊ ಲಿಸ್ಟ್ ಆಫ್ ಲಿಂಕ್ಸ್ ಹೇಗೆ ಬರುತ್ತೆ? ಸೊ ಅದೇ ಕೀವರ್ಡ್ ಬೇಸ್ ಮೇಲೆ ನೀವು ಅದನ್ನು ಯಾವುದು ಬೇಕಾದ್ರೂ ನೋಡ್ಬೋದು. ಈ ಲಿಂಕ್ ಚೆಕ್ ಮಾಡೋದು, ಈ ಲಿಂಕಲ್ಲಿ ಚೆಕ್ ಮಾಡೋದು ಅಂತ ನಾವು ಹೇಳ್ತೀವಿ. ಸೊ ಅದನ್ನು ಆ ಥರ ಸೆಟ್ ಆಫ್ ಲಿಂಕ್ಸೇ ಏನಕ್ಕೆ ಬರುತ್ತೆ, ಹೇಗೆ ಬರುತ್ತೆ? ಸೊ ದೇರ್ ಬೈ ಇಟ್ ವಿಲ್ ಗೋಯಿಂಗ್ ಟು ಲೈಕ್ ದಟ್ ಈಸ್ ಹೌ ದ ಕ್ಲಸ್ಟರಿಂಗ್ ಗೋಯಿಂಗ್ ಟು ಹ್ಯಾಪನ್. ಲೈಕ್ ಒಂದು ಕೀವರ್ಡಿಗೆ ಅದಕ್ಕೆ ಲಿಂಕ್ ಆಗುವಂಥ, ಅದಕ್ಕೆ ಸಿಮಿಲರ್ ಬರುವಂಥ ಕಂಟೆಂಟ್ ಇರುವಂಥ ಬೇರೆ ಬೇರೆ ವೆಬ್ಸೈಟ್ಸ್ಗಳೆಲ್ಲ ಒಂದು ಗ್ರೂಪ್ ಆಗಿ ನಿಮಗೆ ಕಾಣಿಸುತ್ತೆ, ರೈಟ್. ಸೊ ಫಾರ್ ಸಮ್ ವೆಬ್ಸೈಟ್, ಫಾರ್ ಸಮ್ ಕೀವರ್ಡ್ಸ್ ವಿಲ್ ಬಿ ಹ್ಯಾವಿಂಗ್ 10 links will be appeared on the screen. For some websites will be having so nothing, no link will be appeared. Okay, so that kind of stuff will going to have in a real-time application. And wireless sensor networks, so to whip up the data of particular employees, particular organization employees. So all the stuff will going to happen by using this K-means clustering technique. Okay. And we have discussed about the K-means clustering technique, and we can so there are too many methods for finding out the distance of data point to the centroid. Okay, so on those too many metrics we can like most popularly use 4 distance metrics. ಓಕೆ, ಸೊ ಅಂದರೆ ಈಗ ನಾವು ಸೆಂಟ್ರಾಯ್ಡ್ ಅಂತ ಫೈಂಡ್ ಔಟ್ ಮಾಡ್ಕೊತೀವಲ್ವ ರ್ಯಾಂಡಮಾಗಿ. ಸೊ ಸೆಂಟ್ರಾಯ್ಡ್ ಅಂತ ಫೈಂಡ್ ಔಟ್ ಮಾಡ್ಕೊಂಡು ಅಲ್ಲಿಂದ ಡಾಟಾ ಪಾಯಿಂಟ್ಸಿಗೆ ಡಿಸ್ಟೆನ್ಸ್ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಆಗುತ್ತೆ ಅಂತ ಹೇಳಿದೆ. ಸೊ ನಾವು ಆಮೇಲೆ ಡಿಸ್ಟೆನ್ಸ್ನ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡೋಕ್ಕೆ ಡಿಫ್ರೆಂಟ್ ಫಾರ್ಮುಲಾಸ್, ಈಕ್ವೇಷನ್ಸ್ನ ಯೂಸ್ ಮಾಡ್ತೀವಿ. ಆ್ಯಂಡ್ ದೋಸ್ ಈಕ್ವೇಷನ್ಸ್ ಆರ್ ಬಿ ರೆಪ್ರೆಸೆಂಟೆಡ್ ವಿತ್ ಡಿಫ್ರೆಂಟ್ ಟೈಟಲ್ಸ್. ಆ್ಯಂಡ್ ಕಾಮನ್ಲಿ ಯೂಸ್ಡ್ ಡಿಸ್ಟೆನ್ಸ್ ಮೆಟ್ರಿಕ್ ಈಸ್ ಯೂಕ್ಲಿಡಿಯನ್ ಡಿಸ್ಟೆನ್ಸ್. And we may use squared Euclidean distance, Manhattan distance, cosine distance. Okay, you can calculate these stuffs to find out the distance between the like centroid and the data point. Okay, so Euclidean distance, like how it is calculated is just by using a new data point to the existing data point coordinate difference. So we'll make a square of it, and we'll going to find out every values distance by this measure. Okay, so ಹೊಸ ಪಾಯಿಂಟ್ಗೂ ಡಿಫ್ರೆನ್ಸ್ನ ಫೈಂಡ್ ಔಟ್ ಮಾಡ್ತೀವಿ, ಕೋಆರ್ಡಿನೇಟ್ ಡಿಫ್ರೆನ್ಸ್ ತೊಗೋತೀವಿ, ಒಂದು ಸ್ಕ್ವೇರ್ ಮಾಡ್ತೀವಿ. ಸೊ ಆ್ಯಂಡ್ ಅದನ್ನು ಸ್ಕ್ವೇರ್ ರೂಟ್ ಆಫ್ that value will going to calculate, and that will makes you the Euclidean distance. ಸೊ ಸ್ಕ್ವೇರ್ ಡಿಸ್ಟೆನ್ಸ್ ಅಂತ ಹೇಳಿದ್ರೆ ಜಸ್ಟ್ ಯೂಕ್ಲಿಡಿಯನ್ ಡಿಸ್ಟಿಗೆ ಸ್ಕ್ವೇರ್ ರೂಟನ್ನು ರಿಮೂವ್ ಮಾಡ್ತೀವಿ. ಓಕೆ, ಸ್ಕ್ವೇರ್ ಆಫ್ ದ ಡಿಸ್ಟೆನ್ಸ್ will go to calculate, that will make you a squared Euclidean distance. And one more is Manhattan distance. So Manhattan distance is simple, and it is going to give the distance by giving the sum of horizontal and vertical components of the distance, or the distance between the 2 points, so measured along the axis at right angles. Okay, so by this equation we are going to give the distance between the data points. And cosine distance measure, so this is also another metric. So it measures the similarity, like it is going to take the angle between the two vectors. Okay, so thereby it is going to find out the distance. So these are the different distance measuring techniques. Okay, so metrics, and thereby it is going to use the multiple, like one or the other metric to find out the distance. Okay, so then afterwards we will just see how does actually K-means clustering will work. Okay, so first what happens, we'll start with our data set. So we'll going to select the value of K. Okay, so the value of K is nothing but number of clusters that we want. ಎಷ್ಟು ಕ್ಲಸ್ಟರ್ಸ್ ಬೇಕು ಅನ್ನೋದನ್ನು ನಾವು ಫೈಂಡ್ ಔಟ್ ಮಾಡ್ಕೋಬೇಕು. ಓಕೆ. ಸೊ ಅದನ್ನು ನಾವು ನಾರ್ಮಲ್ ರ್ಯಾಂಡಮ್ ಆಗಿ ತೊಗೋತೀವಿ. ಓಕೆ. ಸೊ ಆ್ಯಂಡ್ ಅಪಾರ್ಟ್ ಫ್ರಮ್ ದಿಸ್, ಟು ಚೂಸ್ ಅ ಬೆಸ್ಟ್ ವ್ಯಾಲ್ಯೂ ಫಾರ್ ಕೆ, ವಿ ಹ್ಯಾವ್ ಟು ಫಾಲೋ ಎಲ್ಬೋ ಪಾಯಿಂಟ್. ಸೊ ಎಲ್ಬೋ ಪಾಯಿಂಟ್ ಈಸ್ ನಥಿಂಗ್ ಬಟ್ like it says like how much minimum the value of k, so that much better clustering will going to happen. ಓಕೆ. ಸೊ ಎಷ್ಟು ಮಿನಿಮಮ್ ವ್ಯಾಲ್ಯೂ ಕೆ ತೊಗೊತೀವಿ ನಮ್ಗೆ ಅಷ್ಟು ಬೆಟರ್ ಆಗಿ ನಮಗೆ ಕ್ಲಸ್ಟ್ರಿಂಗ್ ಕ್ರಿಯೇಟ್ ಆಗುತ್ತೆ, ಕ್ಲಸ್ಟರ್ಸ್ ಕ್ರಿಯೇಟ್ ಆಗುತ್ತೆ ಅನ್ನೋದು ಎಲ್ಬೋ ಪಾಯಿಂಟ್ ಹೇಳುತ್ತೆ. ಓಕೆ. ಸೊ ಆ್ಯಂಡ್ ಇಟ್ಸ್ ಲೈಕ್ will be a graph it's going to create for the data set. Okay. ಹಾಗೆ ಎಲ್ಬೋ ಪಾಯಿಂಟ್ನ ಯೂಸ್ ಮಾಡ್ಕೊಂಡು ನಾವು ಕೆ ವ್ಯಾಲ್ಯೂನ ಚೂಸ್ ಮಾಡ್ಕೊತೀವಿ. ಸೊ ಆಫ್ಟರ್ ದಟ್ ವಿ ಆರ್ ಗೋಯಿಂಗ್ ಟು ಮೆಷರ್ ದ ಡಿಸ್ಟೆನ್ಸ್ ಬಿಟ್ವೀನ್ ದ ಡಾಟಾ ಪಾಯಿಂಟ್ ಬಿಟ್ವೀನ್ ದ ಕ್ಲಸ್ಟರ್ ಸೆಂಟ್ರಾಯ್ಡ್ಸ್ ಆ್ಯಂಡ್ after grouping based on the minimum distance. After that reposition the centroids if the clusters are unstable, as I said, like if the points are moving from one cluster to another cluster after changing the every centroid, so that means unstable clusters will be there. So if the clusters are unstable, we have to repeat the same thing, and once the clusters become stable, we'll going to converge. So we'll going to conclude the point. So after that the clustering technique will going to be completed. Okay. If the clusters are unstable in the sense like it will going to vary, like one cluster and ಇನ್ನೊಂದು ಕ್ಲಸ್ಟರಿಗೆ ಒಂದು ಸೆಂಟ್ರಾಯ್ಡ್ ಚೇಂಜ್ ಮಾಡಿದ ತಕ್ಷಣ ಚೇಂಜ್ ಆಗ್ತಾ ಇರುತ್ತೆ. ಸೊ ಆ ಥರ ಚೇಂಜಸ್ ಏನಿಲ್ಲ ಅಂದರೆ ನಾವು ಅಲ್ಲಿಗೆ ಸ್ಟಾಪ್ ಮಾಡ್ತೀವಿ. ಓಕೆ. ಸೊ ಅದಾದಮೇಲೆ ಏನು ಮಾಡ್ತೀವಿ, ಫೈನಲಿ ವಿ ಗಾಂಟ್ ಟು ಕನ್ವರ್ಜ್. ಓಕೆ. ಸೊ ದಿಸ್ ಇಸ್ ಹೌ ದ ಎಲ್ಬೋ ಪಾಯಿಂಟ್ ವಿಲ್ ಬಿ ದೇರ್. ಓಕೆ. ಸೊ ಎಲ್ಬೋ ಪಾಯಿಂಟ್ ಏನಿದೆ ಈ ಥರ ಇರುತ್ತೆ. ಸೊ ಈ ಎಲ್ಬೋ ಪಾಯಿಂಟಲ್ಲಿ ಏನಿರುತ್ತೆ, ಬೆಸ್ಟ್ ವ್ಯಾಲ್ಯೂ ಆಫ್ ಕೆನ ಚೂಸ್ ಮಾಡ್ತೀವಿ. ಓಕೆ. ಸೊ ದಿಸ್ ಇಸ್ ಹೌ ದ ಎಲ್ಬೋ ಪಾಯಿಂಟ್ ವಿಲ್ ಬಿ ದೇ. ಓಕೆ. ಸೊ ಇಲ್ಲಿ ಏನಾಗುತ್ತೆ ನೋಡಿ, ನಂಬರ್ ಆಫ್ ಕ್ಲಸ್ಟರ್ಸ್ ಯಾವ ಥರ ಜಾಸ್ತಿ ಆಗ್ತಾಯಿದೆ. ಸೊ ಅದರ ಬೇಸ್ ಮೇಲೆ ವಿತಿನ್ ಸಮ್ ಆಫ್ ಸ್ಕ್ವೇರ್ಸ್, ದಟ್ ಈಸ್ ನಥಿಂಗ್ ಬಟ್ ಯುವರ್ ನಂಬರ್ ಆಫ್ ಏರರ್ಸ್. ಓಕೆ. ಸೊ ಏರರ್ಸ್ ಅಷ್ಟು ರೆಡ್ಯೂಸ್ ಆಗ್ತಾ ಬರುತ್ತೆ ಅಂತ. ಓಕೆ. ಸೊ ಬೇಸ್ಡ್ ಆನ್ ದಿಸ್ ವಿ ಆರ್ ಗೋಯಿಂಗ್ ಟು ಫೈಂಡ್ ಔಟ್ our best value for k. Okay. So that is how k-means clustering will going to work. Okay. Just have the steps here. Okay. So whatever the things that I have told, so that steps will be represented here as statements. Okay. So we shall just see now an example for k-means clustering. Okay. So just take a set, data set. Just a sec. Just created a simple set of values here. Okay. ಸೊ ಇಲ್ಲೇನು ಮಾಡಿದ್ವಿ, ನಾವೇ ಒಂದು ಸಿಂಪಲ್ ಡಾಟಾ ಸೆಟ್ ವ್ಯಾಲ್ಯೂಸ್ ಇದ್ರಾಗೆ ಎಕ್ಸ್ ಆ್ಯಂಡ್ ವೈ ಕೋಆರ್ಡಿನೇಟ್ ವ್ಯಾಲ್ಯೂನ ತೊಗೊಂಡಿದ್ದೀವಿ. ಓಕೆ. ಅಂತ ಎಕ್ಸ್ ಆ್ಯಂಡ್ ವೈ ವ್ಯಾಲ್ಯೂಸ್ ತೊಗೊಂಡಿದ್ವಿ. ಸೊ ಇದನ್ನು ನಾವು ಗ್ರೂಪ್ಸ್ ಮಾಡಬೇಕು. ಎಷ್ಟು ಗ್ರೂಪ್ಸ್ ಆಗಿ ಮಾಡಬೇಕು, ಜಸ್ಟ್ ಗಿವ್ ದ ವ್ಯಾಲ್ಯೂ ಆಸ್ 3, ನಂಬರ್ ಆಫ್ ಕ್ಲಸ್ಟರ್ಸ್ ಆಸ್ 3. ಸೊ ಡಾಟಾ ಸೆಟ್ನ ಕ್ರಿಯೇಟ್ ಮಾಡಿಕೊಂಡು ಜಸ್ಟ್ ಪ್ಲಾಟ್ ಮಾಡಿದ್ದೀವಿ ಅಷ್ಟೇ, ಅಂದರೆ ಎಂಟೈರ್ ಡಾಟಾ ಸೆಟ್ ಸ್ಯಾಂಪಲ್ಸ್ ಯಾವ ಥರ ಡಿಸ್ಟ್ರಿಬ್ಯೂಟ್ ಆಗಿದೆ ಅಂತ. ಸೊ ಇದನ್ನು ಕ್ಲಸ್ಟರ್ಸ್ ಮಾಡಬೇಕು ಇವಾಗ ನಾವು. ಸೊ ಕ್ಲಸ್ಟರ್ಸ್ ಮಾಡೋದು ಹೇಗೆ, for that purpose we'll just use the method called k-means. So this is imported by using the library sklearn.cluster. Okay. So clusters in the means ಇಂಪೋರ್ಟ್ ಮಾಡ್ಕೊಂಡು ಮೆಥಡ್ನ ಯೂಸ್ ಮಾಡ್ತಾ ಇದ್ದೀವಿ. ಸೊ ಎಷ್ಟು ಕ್ಲಸ್ಟರ್ಸ್ ಬೇಕು ಇನಿಷಿಯಲಿ ನಾವು ಕೊಡ್ತೀವಿ. ಸೊ ದ್ಯಾಟ್ ಈಸ್ 3. ಸೊ ಅದಾದಮೇಲೆ ನಮ್ಮ ಡಾಟಾ ಸೆಟ್ನ ಈ ಆಬ್ಜೆಕ್ಟಿಗೆ ಮಾಡೆಲಿಗೆ ಫಿಟ್ ಮಾಡ್ತೀವಿ. ಸೊ ಫಿಟ್ ಮಾಡಿದ ಮೇಲೆ ಏನಾಗುತ್ತೆ, ಸೊ ಕ್ಲಸ್ಟರ್ಸ್ ಸೆಂಟ್ರರ್ಸ್ ರ್ಯಾಂಡಮಾಗಿ ಏನು ಚೂಸ್ ಆಗುತ್ತೆ, ಆಮೇಲೆ ಮಾಡಿಫೈ ಆಗ್ತಾ ಬಂದು ಫೈನಲಿ ಏನು ಬಂದಿರುತ್ತೆ ಆ ಸೆಂಟ್ರಾಯ್ಡ್ಸ್ ಡಾಟಾ ಪಾಯಿಂಟ್ಸ್ ನಮಗಿಲ್ಲಿ ಸಿಗುತ್ತೆ. ಸೊ ಆ್ಯಸ್ ವಿ ಮೆನ್ಷನ್ಡ್ ಆ್ಯಸ್ 3. ಸೊ 3 ಅಂತ ಮೆನ್ಷನ್ ಮಾಡೋಕ್ಕೆ 3 ಸೆಂಟ್ರಾಯ್ಡ್ಸ್ ವಿಲ್ ಬಿ ರಿಟರ್ನ್. ಸೊ ಆ್ಯಂಡ್ ಇಷ್ಟು ಸ್ಯಾಂಪಲ್ಸ್ ಏನಿದೆ, 1 2 3 4 5 6 7 8 9. ಓಕೆ. ಈ 9 ಸ್ಯಾಂಪಲ್ಸು ಯಾವ್ಯಾವ ಕ್ಲಸ್ಟರಲ್ಲಿದೆ ಅನ್ನೋದು ನಿಮಗೆ ಫೈನಲ್ ರಿಸಲ್ಟ್ ಬರುತ್ತೆ. ಓಕೆ. ಫಸ್ಟ್ ಡಾಟಾ ಪಾಯಿಂಟ್ ದಟ್ ಈಸ್ 5, 3 will be in cluster 2. Okay. Second is also in cluster 2, third is also in cluster 2, fourth is cluster 3, first, 5th, 6th, 7th will be in cluster 1. So like in the first cluster, second cluster, third cluster. And first cluster will always be given with the value 0, second will be given with the 1, third will be given with the value 2. So last cluster will be in cluster 1, so that is in cluster 0. Okay. So ಇದನ್ನ ಪ್ಲಾಟ್ ಮಾಡಿದ್ರೆ, ಸೊ ವಿಲ್ ಬಿ ಹ್ಯಾವಿಂಗ್ ಯಾವ್ಯಾವ ಡಾಟಾ ಪಾಯಿಂಟ್ಸು ಯಾವ ಕ್ಲಸ್ಟರಲ್ಲಿ ಬಂದಿದೆ ಅನ್ನೋದು ನಿಮಗೆ ಗೊತ್ತಾಗುತ್ತೆ. ಓಕೆ, ಸೊ ಗ್ರಾಫ್ಸ್ನ ಪ್ಲಾಟ್ ಮಾಡಿದ್ವಿ. ಸೊ ವಿಲ್ ಬಿ ಹ್ಯಾವಿಂಗ್ ಡಿಫ್ರೆಂಟ್ ಕ್ಲಸ್ಟರ್ಸ್ ಹಿಯರ್. Okay, so if you want to know the centroids finally, which are finally decided, so here are the centroids. ಬ್ಲ್ಯಾಕ್ ಕಲರ್ ಏನು ಕಾಣ್ತಾ ಇದೆ, ಸೊ ಅದನ್ನು ಸೆಂಟ್ರಾಯ್ಡ್ಸ್, ಕ್ಲಸ್ಟರ್ ಸೆಂಟರ್ಸ್ ಏನಿದೆ ಅವನ್ನ ಡ್ರಾ ಮಾಡ್ತೀವಿ. ಅದನ್ನು ಗ್ರಾಫ್ನ ಪ್ಲಾಟ್ ಮಾಡಿದಾಗ ಹಿಯರ್ ಆರ್ ದ ಪಾಯಿಂಟ್ಸ್. Okay, so this is how k-means clustering is going to happen. We just give the data set to the k-means algorithm. Okay, so we'll give the n clusters, so how many clusters we want, so that we are going to give, and for that after that we are going to fit our data set to the k-means clustering model, and after that we are going to get the results as a grouped clusters, different clusters. Okay, so this is how the clustering can be implemented. Okay, we'll see another example of k-means clustering by using the application of customer segmentation. Okay, so we'll just have the use data set, so that contains information about the customer ID, gender, age, and what is the annual income in terms of dollars, $1,000, and what is the spending score. So based on this information we have to segment our customers. Okay, so how we will go into a segment, so that is what the point here. Okay, first thing we are going to import the data set. After we will explore it, so we'll split up the data set into like we have performed the data pre-processing. Okay, after that we are going to get the independent and dependent variable, independent data set. Okay, so we'll just take the last two columns, annual income and spending score. Okay, based on these two steps we have to create the clusters. Okay, so we'll import the model. So after that we just try to draw the elbow method. Okay, so elbow method for this data set, this will be the elbow method. So elbow method score ನ ಡ್ರಾ ಮಾಡಿದ್ರೆ ನಮಗೆ ಎಲ್ಲಿ ನಿಮಗೆ ಯಾವ ವ್ಯಾಲ್ಯೂ ಆಫ್ ಕೆಗೆ ಆಪ್ಟಿಮಮ್ ರಿಸಲ್ಟ್ಸ್ ಬರ್ತಾ ಇದೆ. ಓಕೆ, ಸೊ ಇಲ್ಲಿಂದ ಡಿಕ್ರೀಸ್ ಆಗ್ತಾ ಎಲ್ಲಿ ಕಾನ್ಸ್ಟೆಂಟ್ ಆಗ್ತಾ ಇದೆ, ಸೊ ಅಟ್ 4 or 5 ವ್ಯಾಲ್ಯೂಸ್. ಓಕೆ, ಸೊ 5 ವ್ಯಾಲ್ಯೂಸ್ ತೊಗೊಂಡ್ರೆ ನಿಮಗೆ ಆಪ್ಟಿಮಮ್ ರಿಸಲ್ಟ್ ಬರ್ತಾಯಿದೆ. ಸೊ ಇಲ್ಲಿಂದ ಡಿಕ್ರೀಸ್ ಆಗಿ ಮತ್ತು ಕಾನ್ಸ್ಟೆಂಟ್ ಆಗ್ತಾಯಿದೆ. ಓಕೆ, ಸೊ ಆಪ್ಟಿಮಮ್ ವ್ಯಾಲ್ಯೂಸ್ ಬರುವಂಥ 5 ವ್ಯಾಲ್ಯೂಸ್ನ ತೊಗೋತೀವಿ. ಓಕೆ, ಸೊ ಅದಾದಮೇಲೆ ಏನು ಮಾಡ್ತೀವಿ, ಜಸ್ಟ್ ಟೇಕ್ ಇಟ್ ಆಸ್ ಗಿವ್ ದ ಕ್ಲಸ್ಟರ್ಸ್, n number of clusters as 5. ಸೊ ಆಫ್ಟರ್ ದ್ಯಾಟ್ ಜಸ್ಟ್ ಡ್ರಾ ದ ಗ್ರಾಫ್. ಓಕೆ, ಸೊ ಕ್ಲಸ್ಟರ್ಸ್ 5 ಅದಾದಮೇಲೆ ಮಾಡೆಲ್ ಫಿಟ್ ಮಾಡ್ತೀವಿ. ಸೊ ಫಿಟ್ ಮಾಡಿದ ಮೇಲೆ ಅದನ್ನು ಪಾಯಿಂಟ್ಸ್ನ ಡ್ರಾ ಮಾಡಿದ್ರೆ, ಪ್ಲಾಟ್ ಮಾಡಿದರೆ ದಿಸ್ ಇಸ್ ಹೌ ದ ಕ್ಲಸ್ಟರ್ಸ್. ಓಕೆ, okay, this is how the results will be given for the clustering algorithm implementation for the mall customer segmentation. Okay, so what are the data points we have here are the clusters. In the like different colors will be giving different clusters here. So we'll be having 5 clusters ಕೊಟ್ಟಿದ್ವಿ. ಸೊ 5 ನಂಬರ್ ಆಫ್ ಕ್ಲಸ್ಟರ್ಸ್ ಅಂತ 5 ನಂಬರ್ ಆಫ್ ಕ್ಲಸ್ಟರ್ಸ್ ಬಂದಿತ್ತು. ಆ್ಯಂಡ್ ಸೆಂಟ್ರಾಯ್ಡ್ಸ್ ಯಾವುದಾದ್ರು ಸೆಂಟರ್ಸ್ ಫೈಂಡ್ ಔಟ್ ಆಗಿತ್ತು ಅದನ್ನೆಲ್ಲ ಇಲ್ಲಿ ಎಲ್ಲೋ ಡಾಟ್ಸಲ್ಲಿ ರೆಪ್ರೆಸೆಂಟ್ ಮಾಡಿದ್ವಿ. ಓಕೆ, ಸೊ ದ್ಯಾಟ್ ಈಸ್ ಹ್ಯಾವ್ and by this we can get the information like as below. Okay, so cluster 1 ಈಗ ನಮಗೆ ಆ್ಯನ್ಯಲ್ ಇನ್ಕಮ್ ಎಷ್ಟಿದೆ, ಜಾಸ್ತಿ ಇದೆ, ಸ್ಪೆಂಡಿಂಗ್ ಸ್ಕೋರ್ 1 to 100 ಅಂದರೆ ಯಾರು ಜಾಸ್ತಿ ಸ್ಪೆಂಡ್ ಮಾಡ್ಬೋದು ಅಂತ. ಸೊ ಇನ್ಕಮ್ ಜಾಸ್ತಿ ಇರೋರು ಕಡಿಮೆ ಖರ್ಚು ಮಾಡ್ತಿರ್ಬೋದು, ಅಥವಾ ಕಡಿಮೆ ಇನ್ಕಮ್ ಬಂದಿರೋರು ಕಡಿಮೆ ಖರ್ಚು ಮಾಡ್ತಾ ಇರ್ಬೋದು, ಅಥವಾ ಜಾಸ್ತಿ ಖರ್ಚು ಮಾಡ್ತಾ ಇರ್ಬೋದು, ಅಥವಾ ಆ್ಯಾವ್ರೇಜ್ ಇನ್ಕಮ್ ಮೀಡಿಯಮಲ್ಲಿ ರೇಂಜಲ್ಲಿರೋರು ಮೀಡಿಯಮ್ ಆಗಿನೇ ಖರ್ಚು ಮಾಡ್ತಾ ಇರ್ಬೋದು, ಲಿಮಿಟಲ್ಲಿ ಖರ್ಚು ಮಾಡ್ತಾ ಇರ್ಬೋದು. ಈ ಥರ ಡಿಫ್ರೆಂಟ್ ಕ್ಯಾಟಗರೀಸಲ್ಲಿ ನಾವು ಗ್ರೂಪ್ ಅಪ್ಸ್ ಮಾಡ್ಬೋದು. ಸೊ ಅದರ ಬೇಸ್ ಮೇಲೆ ನಾವು ಈ ಥರ ರಿಸಲ್ಟ್ನ ಅನಾಲಿಸಿಸ್ ಮಾಡ್ಕೋಬೇಕು. ಸೊ ಕ್ಲಸ್ಟರ್ 1 ಇದೆ, ಕ್ಲಸ್ಟರ್ 1 ಈಸ್ ಆಫ್ ರೆಡ್ ಕಲರ್. ಸೊ ರೆಡ್ ಕಲರಲ್ಲಿ ಏನಿದೆ, ಸೊ ಅರ್ನಿಂಗ್ ಹೈ ಬಟ್ ಸ್ಪೆಂಡಿಂಗ್ ಲೆಸ್. ಬ್ಲೂ ಕಲರ್ ಏನಿದೆ, ಅರ್ನಿಂಗ್ ಆ್ಯಾವ್ರೇಜ್ ಇನ್ ಟರ್ಮ್ಸ್ ಆಫ್ ಅರ್ನಿಂಗ್ ಆ್ಯಂಡ್ ಸ್ಪೆಂಡಿಂಗ್. ಸೊ ನೆಕ್ಸ್ಟ್ ಈಸ್ green color, cluster 3 is in green color. Spending is high, earning is also high. Okay, and sky blue color, that is cyan color. So cyan color cluster ಏನಿದೆ, ಸೊ ಇಲ್ಲೇನಾಗುತ್ತೆ, earning less but spending more. Okay, but in pink cluster, so it is earning less and spending is also less. Okay, so this is how we can group up our we can give the meaning for these clusters. We can analyze the data like this and the results. Okay, so this is how we can implement the k-means clustering algorithm. Okay, sorry. And this is how we can also implement different clustering techniques, and thereby we can analyze the results and use these results for the different purposes. Okay, and we can use the results for the different ಔಟ್ಪುಟ್ಸ್. ಈಗ ಡಿಫ್ರೆಂಟ್ ಪ್ರೆಡಿಕ್ಷನ್ಸ್ಗೆ, ಡಿಫ್ರೆಂಟ್ ಅನಾಲಿಸಿಸ್ಗೆ ಯೂಸ್ ಮಾಡ್ತೀವಿ. ಡಿಫ್ರೆಂಟ್ ಸ್ಕೀಮ್ಸ್ನ ಇಂಟ್ರೊಡ್ಯೂಸ್ ಮಾಡ್ತೀವಿ. ಔಟ್ಪುಟ್ನ ಬೇರೆ ಬೇರೆ ಪರ್ಪಸಿಗೋಸ್ಕರ ಯೂಸ್ ಮಾಡ್ಕೋತೀವಿ. ಓಕೆ, ನಾಟ್ ಓನ್ಲಿ ಫಾರ್ ಅ ಪರ್ಟಿಕ್ಯುಲರ್ ರೀಸನ್ ವಿ ಆರ್ ಗೋಯಿಂಗ್ ಟು ಯೂಸ್ ದ ರಿಸಲ್ಟ್. ಓಕೆ, ಬಟ್ ಇನ್ ಕೇಸ್ ಆಫ್ ರಿಗ್ರೆಷನ್ ಅಥವಾ ಕ್ಲಾಸಿಫಿಕೇಷನ್ ಮಾಡಿದ್ರೆ ಲೈಕ್ ಇದನ್ನೇ ಅಂತ ಪ್ರೆಡಿಕ್ಟ್ ಮಾಡೋದಕ್ಕೆ ಯೂಸ್ ಮಾಡ್ತೀವಿ. ಬಟ್ ಇನ್ ಕೇಸ್ ಆಫ್ ಕ್ಲಸ್ಟರಿಂಗಲ್ಲಿ ಏನಾಗುತ್ತೆ, ಡಿಫ್ರೆಂಟ್ ಪರ್ಪಸಸ್ಗೆ ಬೇಕಾದ್ರೆ ನಾವು ರಿಸಲ್ಟ್ಸ್ನ ಯೂಸ್ ಮಾಡ್ಕೊಬೋದು. ಈ ಗ್ರೂಪ್ ನಾನು ಅನಾಲಿಸಿಸ್ ಪರ್ಪಸಿಗೆ ಯೂಸ್ ಮಾಡ್ಬೋದು, ನಮ್ಮ ಅಕೌಂಟ್ಸ್ ಎಷ್ಟು ಬರ್ಬೋದು ಅಂತ ಯೂಸ್ ಮಾಡ್ಬೋದು. ಈ ಗ್ರೂಪಿಂದ ಜಾಸ್ತಿ ಬರುತ್ತಾ, ಈ ಗ್ರೂಪಿಂದ ಜಾಸ್ತಿ ಬರುತ್ತಾ, ಅಥವಾ ಇವ್ರು ಮಾಡ್ತಾರೆ, ಇವ್ರಿಗೆ ಏನಾರು ಆ್ಯಕ್ಷನ್ ತೊಗೋಬೋದಾ, ಅಥವಾ ಇವ್ರಿಗೆ ಏನಾದ್ರು ಸ್ಕೀಮ್ಸ್ ಇಂಟ್ರೊಡ್ಯೂಸ್ ಮಾಡ್ಬೋದಾ, ಈ ಥರ ಏನೇನೋ ಬೇರೆ ಬೇರೆ ಪರ್ಪಸಿಗೆ ಎಲ್ಲ ಯೂಸ್ ಮಾಡ್ಕೋಬೋದು. ಓಕೆ, ಸೊ that is how unsupervised learning is going to happen for the k-means clustering technique. Okay, like in specifically k-means clustering implement ಮಾಡಿದೆ. ಸೊ ಇದೇ ಥರನೇ ಡಿಫ್ರೆಂಟ್ ಕ್ಲಸ್ಟರಿಂಗ್ ಟೆಕ್ನಿಕ್ಸ್ ಆಗುತ್ತೆ. ಒಂದು ಪರ್ಟಿಕ್ಯುಲರ್ ವೇನಲ್ಲಿ ಒಂದು ಪರ್ಟಿಕ್ಯುಲರ್ ಎಕ್ಸ್ಪ್ರೆಷನ್ನ ಇಂಪ್ಲಿಮೆಂಟ್ ಮಾಡೋದು, ಅಥವಾ ಈ ಥರ ಡಿಸ್ಟೆನ್ಸ್ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡೋದು, ಅಥವಾ ಒಂದು ಎಕ್ಸ್ಪ್ರೆಷನ್ನ ಇಂಪ್ಲಿಮೆಂಟ್ ಮಾಡೋದು. ಸೊ ಇದು ಬೇಸ್ ಮೇಲೆ ಡಾಟಾ ಪಾಯಿಂಟ್ಸ್ ಏನಿದೆ, ನಮ್ಮ ಸ್ಯಾಂಪಲ್ಸ್ ಏನಿದೆ ಅವೆಲ್ಲ ಗ್ರೂಪ್ ಆಗುತ್ತೆ ಒಂದು ಸ್ಟ್ರಾಟಜಿ ಬೇಸ್ ಮೇಲೆ. ಆ ಗ್ರೂಪ್ ಆಗಿದ್ದ ಸ್ಯಾಂಪಲ್ಸ್ ನಮಗೆ ಗ್ರೂಪ್ ಆಗಿದ್ದ ಸ್ಯಾಂಪಲ್ಸ್ ಕ್ಲಸ್ಟರ್ಸ್ ಆಗಿ ನಿಮಗೆ ರಿಸಲ್ಟ್ ಕೊಡ್ತೀವಿ. ಆ ರಿಸಲ್ಟನ್ನು ನಾವು ಮಲ್ಟಿಪಲ್ ಪರ್ಪಸ್ಗೋಸ್ಕರ ಯೂಸ್ ಮಾಡ್ತೀವಿ. ಆ್ಯಂಡ್ ಹಿಡನ್ ಪ್ಯಾಟ್ರನ್ ಏನಿದೆ ದ್ಯಾಟ್ ವಿಲ್ ಬಿ ಅನಲೈಸ್ಡ್ ಬೈ ದ ಮಷೀನ್, and through the algorithms, through these strategies. Okay, so that is what for the today's session. Okay, so I'll upload this data set in the classroom, Google Classroom, and you can download this data set and try to implement the same algorithm for this data set and try to differentiate the clusters. Okay, fine. So that's all for today's session. So if you got any doubts, please intimate us and please talk to us. Okay, fine. Thank you.